In this video, we will have a look into hooking a C function. For example, the string compare within the C library. And this means we are not having access from our Java side, so we cannot simply hook those parameters or this return value in this function over here. And this sounds to be a very rough task. But to be honest, it isn't. Figuring out where this function is in this library, of course, this will be very rough, and therefore I would like to split this video into two parts. The first part will be about reverse engineering a native library. This will be a little bit complicated. So we will face ARM assembly, but on a very high level. So we will skip out all the rest and we only focus on the most important parts. This type of reverse engineering, it's a whole course on itself. Nevertheless, I would like to give you at least a preview on how you could do this. Because then you know what you're looking for and then you can navigate around on your own in this code. I mean, on a high level, yes, of course, we cannot learn ARM assembly in just a few minutes, but I guess this will help you a lot in understanding the code, or at least the important part of the code, and also to find the function what you're looking for, to solve really hard challenges or tasks. Alrighty? Okay. The second part will be about hooking this string compare function, and this will be a lot of fun. Because we do not have to learn many new things. Most of them are already known. And the only thing we need to do is we need to bring them together. So we need to complete our puzzle with everything we know about hooking a native function. Alrighty? Okay. After finishing this lecture, we will have our final challenge. And this will be a real-world application, a real-world capture the flag. And if we can solve this, we will obtain our last belt, the red belt. And this is freaking amazing because it shows how many things we have learned in this chapter over here. But for now, let's do this step by step. So we start with a little challenge I have prepared for you. And this is performing a check within a plain C function. This is something we have to figure out and also to identify that this one is happening. And then we will be able to hook it. So we can observe the parameters of the C function and also the return value. Therefore, I would suggest let's start with this one. Let's switch back to the Ubuntu VM and have a look into this application. Let's go. Okay, so here we are back at the Ubuntu VM and now let's have a look into this little exercise I have prepared for you. So within the attachment of the section, you can find this application named cfunc Frida. And let's put this into a new directory, cfunc Frida. And now let's have a look into this one. So we're getting our smartphone screen, this one. And now we are opening a new terminal in this directory and we are using adb install on this application. And there we have it. So we've got a very well placed, amazing looking icon over here. And you can see those colors. These are now the signature apps for this course over here. Let's open this and wow. Even more amazing, this layout and all this, this background and all the other colors, right? Absolutely, you are absolutely right on this one. Okay, we also got this motivating text, give this application a try. And this is definitely something you should do. Here we're having our flag. So let's see what's the functionality of this app. If we're inserting a text, let's see. Then we can see the flag is wrong. So test seems not to be our flag. And to be honest, this is the whole functionality of this application. There isn't much more in there. We're having a function that's checking if our flag is being correct or not. Therefore, let's have a look into this one. So let's reverse engineer this with JDX GUI and let's see what's inside. Okay, so we go into the Android manifest XML. And here we can see we are only having one activity, the main activity, no permissions, nothing fancy in there. So we double click on this one. And here we can see, okay, we've got public native. So this is our native method, hide and seek. We can see we are also loading this library, native lib. If you take a look into this lib directory, here we have them. In this one, this is ARM64, ARM32, x86, which is 32-bit, and this one is x86, 64-bit. All right. This means by having these directories, this application also works in our virtual machine. We have those dependencies over here. Nevertheless, I would like to use it on a real smartphone over here. So that's way faster for me. But you can also try this on the virtual machine. It should definitely work. Alrighty, now let's see. We've got this method hide and seek. This one is being called over here, and we can see, okay, this one has an object which is being fetched from the added text field. This is this one over here. This one. This is our added text field. Okay, so the text we are putting into this one will be forwarded to this function. We're having a string as a parameter and a string as return value. And now we already might realize something. Here we can see the text view will be set to the return value over here. And if we are having a look, the return value is now flag is wrong. So this is the return value. And this means we have no influence regarding to the check itself. Let me put this on the right maybe. Okay, and now let's get out the graphic tablet and yeah, let's talk about this one. Okay, so let's get these pieces together. We've got a function which is named hide and seek. Hide and seek. This one has a string as a parameter. This is an object. Okay, this one is also returning back a string. And it's being a native function. Okay. Now let's figure this out. This one over here, this is our parameter. This is the object that's being provided to this function over here. The function is returning back a string, which is this one over here. So this is the string and the string will be displayed over here. Alright, this means we have no influence regarding to the check because the check is being performed within this function itself. Let me clean this here. Okay, so if this one here is the function, then what we can hook for now is the following. We can hook the parameter, of course, and we can hook the return value over here. But none of them is related to the check itself. The check might be performed within this function, within another function. For example, this string compare function, which takes our object, our parameter, and compares it against, I'm running out of color, so I'm taking blue once again, against this value, which is our flag. And now the only thing we can influence is this one. But this is also something we could simply type in here. Then we are getting back an return string, which claims if the flag is wrong or if the flag might be correct. Okay? The thing we need to do is we need to figure out where this function is or what this function over here is, and then we need to apply our hook in there. So we need to hook into this one and yeah, observe those parameters and also the return value of this one. And this is something we can of course also do with reader. If you're having the address of this one, then everything is easy because it's exactly the same approach. But how do we get this address over here? And therefore we have to do a little bit of research because we do not know what this function over here is. It might be in string compare, but it might be something different. We have to reverse engineer this native library to figure out what this one over here is. And if you know this, then we can hook this. Alright? Okay, I mean, if you would like to cheat on yourself, what you can also do is you can simply modify the return value over here. So you can claim that the flag has been correct. But this is not the approach we would like to take over here, because modifying a string within the output is not modifying the check itself. This one over here. So we would simply just cheat on ourselves, and let's assume we've got the following case. So let's assume this one over here, this is a cryptographic functionality that takes our input and compares this input against a static key. If we are able to figure out what the static key is, then we are able to decrypt all these configuration files that contains passwords, sensitive information, access tokens, and things like this. If we are simply just modifying the output that the decryption has been successful, we are not getting anything right now. And so the things we need to do are the following. We need to get this native library, libnative-libso, and we need to disassemble it. Then we need to identify where this function is being used, our native function, and then we have to identify where this check is being performed. And to be honest, this has been a really rough task a few years ago. But till 2019, we're having an amazing tool out there that helps us a lot. And this amazing tool, it's ghidra. Ghidra has also a decompiler for several different architectures, including the ARM architecture, which means beside having the assembly code, we are also getting out pseudo C, C++ code. Okay, this is not that accurate like the Java code because this task it's freaking hard to even be performed. But the output, it's ridiculous how good we can read this, and by tweaking it a little bit, we can absolutely use it for our reverse engineering approach. And this is where this first part is about. Reverse engineering this library and identifying this check functionality, which can be then, in the second part, easily be hooked. Alrighty? Okay, so therefore, let's start. Let's start installing ghidra and let's figure out how this is being done. And let's go. Okay, so the first thing we need to do is we need to extract the native library out of this application. But this is absolutely not a big deal. We can simply go into this APK and we can right-click, extract here. So this is a zip archive and we can simply extract this content in there. And let's do this. So here we have this now. And within lib, we are now having those libraries. All right. If you're already familiar with assembler, then you have the free choice to go for what's the most comfortable architecture for you right now. Here we're having ARM64, ARM32, x86 and also 64-bit version. And for me right now, I like to stick to ARM32-bit version. And this is the architecture where I feel safe right now. So this one over here. Okay, to analyze this application, we first need to get our tool of choice. And my tool of choice, it's ghidra. Ghidra is freaking amazing and therefore let's install it. We go into our well-famous internet. Here we have it. And that's the official page, ghidra-sre.org. And here we can also download it directly from GitHub. So if we click on this one, here we have the version 10.01. We click on this one and now we're downloading it. Okay, so the download has been finished and we also have this SHA-250 thick sum to verify if our downloaded file is exactly the same over here. And therefore, let's verify this. So within downloads, we are now providing a SHA-250 thick sum, or we're generating a new one over this zip archive. This might take a while because it's a little bit large, but here we can see this is what we've got and this is what it should be. This matches perfectly. All right. So please only download ghidra from the official page over here. Okay. So now we have downloaded it. Downloads and here we have it. I double click on this one and then we hit extract and we extract this into our tools. There we have it. All right. Meanwhile, I do some, a little bit of a cleanup. Okay, so the extraction has been finished. We click on show files and here we have it. I rename this real quick to ghidra. And this one over here, that's the starting script. So we can take a quick look into this. But by verifying this SHA-sum, we can be pretty sure that that's the intended file over here. So okay, this is just a bash script that launches ghidra, but we would have to take a look into this one and go down the rabbit hole. For me right now, I trust it, but feel free to do your own investigation on this one. Alrighty, so, one too much. Maybe let's go into this one once again. Okay, let's start ghidra. So we are simply starting the script and this will launch, this application launcher here. Okay, here we're having now the project overview, and for now we are not having any ghidra project. So we are creating a new one. New project. Here we have the option between non-shared project and shared project. And this one is for multiple people working on the same file. This is here not the case. So we are the only person who are working on this project right now. So we click non-shared and here we have to define a project name. This is the function Frida. Okay, and then we simply can click finish and that's all for now. So here we have created our new project. By the way, ghidra has now this amazing debug feature. So this was long required and finally in version 10 it's there. But we do not want to debug it. We want to disassemble this application And this is what this dragon is for. The dragon is the code browser. So we hit this. And then let's see. Alright, so here we have it. Maybe I have already started or installed ghidra before on this machine over here. Normally there should be some pop-up regarding to an user agreement and things like this. So please read carefully through this, and if you accept them, then you can simply hit the accept button. And then you should be now synchronized once again. So this is now the code browser, and what we need to do is we need to load our library into this one. In my case, I'm choosing the ARM 32-bit version. So I go into File and then Import File, this one over here. And then I go into Apps, cfunc Frida, and this one, the library, and then here we have it, libnative-libso, the ARM 32-bit version. I click Select File to import, and here we can now see, yeah, that's the pop-up of ghidra. So ghidra has already identified the architecture. We can see this one is an ARM Little Endian 32-bit V8 version. And this fits perfectly. So we can simply use this or keep the default value over here. Then all we need to do is we simply need to click OK. Okay, now the application is being loaded and there's a quick checkup until this pop-up appears. The libnative-libso has not been analyzed. Would you like to analyze it now? And this is definitely something we want to have. Otherwise, ghidra is not creating those nice tables regarding to functions, pointers, variables, strings, and stuff like this. So we definitely want to analyze this native library over here. I click yes, and now we've got a very important pop-up. These are the default values, and the only thing I would like to add are the following two. I would like to use the ARM Aggressive Instruction Finder, because ARM has two modes. One of them is the ARM mode and the other one is the thumb mode. The ARM mode means every instruction is 4 bytes long. Within the thumb mode, every instruction is 2 bytes long, and Frida has this amazing feature trying to detect if the code section is ARM mode or thumb mode. The other option is the decompiled parameter ID, this one. This will help us to reverse engineer this application. We get some additional information within the parameter IDs. And so therefore I also activate this one. Alright. And yeah, so that's all. The default values plus the compiler parameter ID and also the ARM Aggressive Instruction Finder. Alrighty? Okay, now we can click the Analyze button. So here we're getting an overview about this binary. For example, the name, IDs, bytes and stuff like this. We can simply ignore this right now. On the bottom right, we can see the progress and also over here. So we can watch ghidra reverse engineering this application. Now we've got a huge section here. And yeah, it has been also finished right now. Perfect. So ghidra has now finished analyzing this native library here. All right, let's have a quick look around this. Okay, in the middle over here, we have gotten code listing, and this is the assembly code. On the left, we've got our symbol tree, which is very important for us right now. We've got imports and exports. So Frida is also making a difference between them, which is also super amazing, because then we can easily see which module we need to use within our Frida script. All right. Beside them, we also have these functions over here, and this might be a little bit duplicated because these functions are also listed in imports or exports, but we can use them to search through this. And for example, let's see which function we want to identify. If we go back into this one, so let's see, within the main activity, the function we're looking for is hide and seek. So let's see, we're going into this filter and we're typing in hide and seek. And there we go, here we have them. And this one is an exported function, and here we have the whole function name. If we click on this, we get directly redirected, maybe let's pull this on the side, to this function in the disassemble view. And now, that's the amazing part about ghidra, we also get a decompiled output on the right. So over here we have now the decompiled output regarding to this assembler overview. In case if you're not really familiar with assembly, we can only stick to this one on the right, and we can already see our parameters. For example, this chain-I environment, which is parameter 1. Then we've got an undefined, so ghidra doesn't know that this one here is this object. And here we're having our chase string. And this is our argument that's being passed into this function. So if we go back into JDX, there we have it. This is our object because the first argument in a chain I function, that's the environment pointer. The second one is this object, and the third one, this is our parameter. In this case, our string we are passing into this. Alrighty? Okay. Let's close this. So let's make this maybe a little bit larger. By looking at this, I already realized something. You may also have seen this so far. This one over here. So here we've gotten string compare. We've got this one. We will take a look into this in a moment. But this one here seems to be a string that's being compared. Might this be our flag? I mean, this wasn't the intention during the creation of this challenge. So ghidra has decompiled this application and figured out there isn't static string, which is being used only once here. So therefore, we are simply just putting this string hard-coded into the string compare function within the decompiler output. So this is not the intended way to solve this challenge, but nevertheless, if this works, then it's an easy way. And if you find something like this, go for the easy way. So there's no reason to flex about this one and make it more complex than it is. And let's try this out if this one is really the flag. So let's get out our smartphone once again. Okay, here we're having the flag. Let's see. We can also use the keyboard, by the way. Insane Frida hooks. Okay. And let's see. So I'm hitting check in 3, 2, 1. Okay, nice. This one is really the flag. And yeah, as already mentioned, this is not the intended way, but it is an easy way. So if you find something like this, go for it. Okay, but now let's assume it's not that easy. So this one over here, this won't be an hard-coded string. So maybe that's a variable that's being concatenated out of many other strings until we reach over here. So the thing we want to do is the following. Maybe let's get out the graphic tablet and discuss this over here. Alrighty, just give me a second. Okay, so here we are back on the graphic tablet, and regarding to this one, we have already identified our comparison function. And this one over here, the string compare. We know this right now because this one here seems to be obviously our flag, this parameter in there. This means this might be our parameter that's being provided to this function over here via the hide and seek method. And this is something we can figure out right now. So maybe let's clean this over here real quick. Here we're having PC_var1, and if we do a middle mouse button click on this one, we get all these occurrence of this variable. And this one is being assigned over here at this line. And this one is using a chain I environment function, getString UTF chars. And this one over here, parameter1, we know this right now. This is our environment pointer regarding to the NDK functions. And this one over here, this is our parameter that's being provided to this function, to this hide and seek function. This is our object. So let's write this down. This one, this is our object. And this one is being used over here. And this one over here, that's our environment pointer. And this one over here, sorry, parameter 2. This one is this object. Okay, and this means this here is args0. This one is args1. And this one over here, this is args2. Okay, if we're going back into the NDK function on the Java side, we can see hide and seek, only one parameter, which means this is our object, our args2, because environment pointer and this object are not listed over here, but they exist in the NDK side. All right? Okay, so nice. We have already identified our parameter that's being used over here. We can now also assign a name to this one. If we click on this, then we hit the L button, and then we can rename this. And for example, to user input. If we click OK, then all these occurrences also change. So now we're having our user input in there. And this one, we can also rename this one. This is our environment pointer, env pointer. Nice. So now it's a little bit more, here, it's a little bit easier to read. Let's see, here we're having getString UTF chars. We can now look this up what this function does. But we can also assume that this one over here is simply just returning a char pointer, which is an array. So we're getting back a string. And this one is now our string that's being used or referenced over here. So this is some kind of typecasting from our user input, this JString, to this native char pointer over here. And this means in PC_var1, this one over here, this is now our user input once again. User input. All right. Now we've got a duplicate name because we have already used it. Then we simply, we can simply char array. Okay, and now we hit the middle button on this one, and then we have all these occurrences of this one. We can see it's being used within the string compare. So we are now comparing in this function our user input with this one over here. And this means the function we are interested in is this one over here, this string compare function. The first parameter over here, this is our user input. And the second one, this is finally our flag. If we're hooking this function, we can also observe these parameters. I mean, our user input, that's not relevant, but this one over here, this would be super nice to fetch. So we can fetch the values that's being used within a string compare function. And if this one here, if this one won't be that easy to recognize, let's say this one over here is also a variable, and it's being it's being complexly generated, so we do not know what this one is, we do not care. Because at this point we need to have the plain text over here. This one. Alrighty? Okay. And regarding to the rest, we do not care about this one. So we can simply ignore the rest. So the things we are interested in is our user input. We need to get this point where we identify what is our user input. And I mean, regarding to an NDK function, it's not really hard. We always got this nice structure. Environment pointer, this object, and then afterwards our user input. And then we can also track this user input down. So for example, it will be used over here. And this one will be assigned to a new variable. And this one is then being used over here. Alrighty? This is all we need to know regarding to reverse engineering an application with ghidra right now. Alrighty, so this is all for part 1 right now. We have seen how we can reverse engineer a native library. So this is now C++ code. And ghidra is also performing an amazing job in reconstructing the source code. I mean, it's not that nice as in Java, but it's absolutely helpful. We get also some assistance over here. Chain.I environment pointer has been recognized. This one not, but it can be replaced by us right now. Maybe let's do this real quick. This object. Okay, and this is our user input. And then all we need to do is we need to track down the user input. Then we have to identify what this method over here is doing. But it's simply just returning a char array, which means this is now our new converted user input. And this one is being used over here. So this is the function we want to hook. Alrighty? Okay. In the next video, we will learn how to hook this function over here. We've got several possibilities and we will discuss all of them in the next video. In case if you have any questions regarding to this topic or regarding to ghidra, feel free to write me a message. Otherwise, I'm looking forward to see you in the next video when we're finally hooking this method over here. Alrighty, see you there.